In this lecture, you'll learn about the replicated database, Quorum, and Epsilon. These are not really data protection topics, but I'm including them in this section because to understand them, you need to know about high availability first. So that's why I'm including this lecture right after the high availability lesson. Vol 0 contains system data for managing the node and cluster, and it's used for the RDB databases and log files. So RDB stands for the replicated database, and it includes system information. It's called the replicated database because it's replicated between all of the nodes in the cluster. Vol 0 is included on every node in the cluster. It does not contain any client data. It's just used for system information. And because it is on every node in the cluster, if we somehow lose vol 0, that can be recreated from the identical vol 0s which are on the different nodes. Vol 0 contains the system information. That's not to be confused with the SVM root volumes. The SVM root volumes, we have an SVM root volume created whenever we create an SVM, and that functions as the root of the namespace of that SVM. We covered vol 0 and the SVM root volumes earlier on in the course. I'm just mentioning vol 0 again here because that's where the replicated database lives. That is where we have our system information. There are 4 RDB units. That is the volume location database, the VLDB, the management gateway, the virtual interface manager, VIF manager, and the blocks configuration and operations manager, BCOM. Let's talk about each of those units in a little bit more detail. So first up, the volume location database. The VLDB contains an index of which node owns each aggregate and which aggregate contains each volume. As the system administrator, it's possible for you to move volumes between different aggregates. The system needs to keep track of where each volume is located, and it's the VLDB that does that. It's cached in memory to speed up the lookup process during client data access. So when the system boots up, it will be read from vol 0 on disk into system memory. Next up, we have the management gateway, and this provides the command line interface. The management gateway enables management of the cluster from any node. So you've seen that when you SSH into the command line, usually you'll go to the cluster management address. From there, you can manage any node in the cluster, but you could actually SSH to the node management address of any of the individual nodes, and from there, you would still be able to manage the entire cluster. Next, we have the virtual interface manager. That, as you would guess from its name, stores and monitors the logical interfaces and the LIF failover configuration for your IP addresses. And finally, we have BCOM, which is the blocks configuration and operations manager. This stores and monitors SAN information, including your LUN map definitions and your initiator groups. Okay, so those are the 4 units that make up the RDB, and the replicated database does have to be replicated between all the nodes in the cluster. Each node needs to know that system information. So each RDB unit, each of the 4 units, has its own separate replication ring. For each unit, one node, so one controller in your cluster, is the master, and the other nodes are secondaries for each unit. Master nodes can be different for each unit. Typically, when it's first set up, your first node in your cluster is going to be the master for each unit. But if you have any nodes being rebooted, then that can cause things to move around. Writes for an RDB unit go to its master and are then propagated to the secondaries through the cluster interconnect. So whenever you make a change to the system information, that is going to be written to the master of the relevant RDB unit, and it's then going to be replicated out to all the other nodes over the cluster interconnect. Okay, let's talk about Quorum next. A healthy RDB unit is in Quorum. That means that a majority of nodes are communicating with each other. So, for example, if you had an 8-node cluster and 5 of your nodes are able to communicate with each other, well, that's a majority of the nodes, so the cluster would be in Quorum. If a master has communication issues over the cluster interconnect with the other nodes, then a new master will be elected by the members of the unit automatically. So all this stuff with the RDB and with Quorum and Epsilon coming up, it's all managed by the system itself under the hood. You don't really need to configure anything here. One node has a tie-breaking ability, Epsilon, for all RDB units. So before we get to Epsilon, Quorum exists to prevent an inconsistent system configuration in case of a split brain cluster. So as an example, let's say that we've got an 8-node cluster and 5 of the nodes can communicate with each other over the cluster interconnect, and the other 3 can communicate with each other. But between those two sets of nodes, the 5 and the 3, the two sets do not have communication with each other. Well, in that case, system changes can only be written to the set of 5 nodes. If we did have 5 nodes up, then the cluster is in Quorum. We can still make changes. And the reason that we have this is if you did have a split brain, if half the nodes in your cluster were split off from the other half of the nodes, you wouldn't want to be able to make system changes to both of those sets, because if you did that, then they would have inconsistent system information. If some of the writes are going to one set and other writes are going to the other set, well, when connectivity was restored between all the nodes in the cluster, you could have conflicting information there, and how would they know which was the correct set of information and how would they recover from that? So we need to make sure that that never happens, and by having the concept of Quorum, that makes sure that you can never be writing 2 different sets of configuration to do for 2 different sets of nodes at the same time. But what if you don't have a majority of the nodes, but you've got exactly half of the nodes have got communication with each other? So again, in our 8-node cluster, rather than having a set of 5 and a set of 3, what if we've got 2 sets of 4 nodes that can communicate with each other? Well, when exactly half of the nodes in the cluster are isolated from the other half, no majority exists. You'd have a 4 and a 4 with our 8-node example. In this case, one node has a weighted vote as a tiebreaker. That is the Epsilon node. And one Epsilon node is Epsilon for the entire cluster. It's not like the RDB units where you've got a separate primary for each unit. With Epsilon, it is one node per the entire cluster. So again, with our example in an 8-node cluster where we had 2 sets of 4 nodes and 4 nodes. In that case, system changes can only be written to the set of nodes, which includes the Epsilon node. So if the Epsilon node is up, then the cluster is still in Quorum and we can still write changes. So when an RDB unit goes out of Quorum, reads from the RDB unit can still occur, but changes to the RDB unit cannot. So for example, if the VLDB goes out of Quorum, so if less than half of the nodes have got connectivity to each other, cluster is now out of Quorum. And for the VLDB, in that case, well, no volumes could be created, deleted, or moved. You can't write any new system information, but you can still do reads. So access to the volumes from clients is not affected. Now, it's important for me to say here that a cluster going out of Quorum, it's not like this is a daily event. This is a very serious and very rare event to happen. For a cluster to go out of Quorum, more than half of your nodes need to be unable to communicate with each other over the cluster interconnect. Obviously, that is not a normal situation. It's very rare. And if your cluster ever does go out of Quorum, obviously, it's very important that you recover, but you fix that as soon as possible. Okay, lastly, let's look at some examples of when our cluster would be in or not in Quorum. So for our example, we've got a 4-node cluster, and you can see over here on the left, our first node is the Epsilon node. And I've just put a line between them here just to show that they've got connectivity to each other. The connectivity would actually be going through the cluster interconnect. Okay, so let's say that our fourth node here loses connectivity with the other three nodes. Well, in that case, we've still got connectivity between 3 nodes out of 4, so there's a majority there, so the cluster is still in quorum. Then the third node fails. Well, its connectivity fails. So now in this case, we've got a 4-node cluster, and we've got that equal halfway split now. So 2 of the nodes do not have connectivity, the other 2 do. Well, one of those nodes is Epsilon. So because we've got that 50-50 split, but Epsilon is available, that acts as a tiebreaker, and the cluster is still in quorum. We can still write system information changes. Then the second node loses connectivity. So now in this case, we've only got 1 node available out of 4. That's less than half. So even though it's the Epsilon node, the cluster is now out of quorum. Next up, let's say that it is the Epsilon node which loses connectivity with the other 3 nodes. Well, in that case, even though it's the Epsilon node, we've still got 3 nodes have connectivity out of 4. That's a majority, so we are in quorum. Then if the third node loses connectivity, we've got that equal 50-50 split now, but because we don't have the Epsilon node, the cluster is out of quorum. Okay, last thing to tell you about is 2-node clusters. 2-node clusters are a special case because if one of the nodes goes down, we've now got that equal 50-50 split. And obviously having Epsilon there wouldn't work, because if node 1 is Epsilon, then if node 2 goes down, then that's fine, we can still write changes. But if node 1 goes down, we can't, because we've got a 50-50 split and we don't have Epsilon. So for 2-node clusters, that normal way of doing things is really just not going to work. We've got a special case there, because no majority exists if either node is unavailable, and it wouldn't work having one of the controllers having Epsilon. So in that case, the RDB is going to manage things under the hood. So this is all going to work internally in the system. Again, you don't need to worry about this. It's going to just work anyway, but you do need to tell the system that it is a 2-node cluster. The way you do that is with the command cluster HA modify configured true. So it's a high availability command to let the cluster know that if one of the nodes does fail and you have that high availability event, don't take the cluster out of quorum because it's a 2-node cluster. We've still got 1 controller available. Thanks for watching. If you want to get hands-on practice with NetApp storage for free on your laptop, then you can download my free ebook, which you can see above my head right now. Also, check out my NetApp Storage Complete course, which will teach you everything you could possibly want to know about ONTAP. Thanks.